WebSockets, server sent events, LongPolling, WebRTC, WebTransport. That's a lot of different things. What are all these things? They're all technologies that help solve a really big problem, a very big problem, a challenge of communicating events from your infrastructure, your servers, your Python, your Node.js, your backend infrastructure, database changes, updates, communicating those changes to a front-end client like a phone or a web browser. There's a lot of different scenarios where you want to communicate events to the device directly, but the device doesn't know when those updates are going to come in. So one of the naive approaches is something called short polling, where it's sort of like, are we there yet? Are we there yet? Are we there yet? You keep asking the server via an API call if there's new data available, or if there's new information. Is this thing ready? I'm waiting on something, or is there a new update or an event? Those updates and events could be something like another user posting data to their database records, and those database records need to be copied over to someone else who's actively participating. Or if any other updates, like an author publishes a story, right? That could be another event that needs to be transmitted or broadcast to everyone. And instead of millions of devices asking if we're there yet, that's extremely inefficient because 99% of the time, there's no new information. So it's much better if we had a mechanism or a protocol to be able to transmit when things change to the device directly, rather than the devices having to ask the server if there's any changes. And so there's a lot of ways to do that. We've got all these different protocols that give us really good approaches and efficient approaches to transmitting events when systems of change are ready to be transmitted to end target devices. We need the ability to send events from the server to the client. That's what WebSockets, server sent events, LongPolling, WebRTC, and WebTransport, this is what these things are for. So say, for example, you definitely do have that use case, that reason, that need to be able to transmit change events from your server, your database, or actions from another user and communicate that over to other users, right? There could be 1 or 100 or 1,000,000 other users that need to receive updates when things change. And that is possible using these protocols. However, there's so many, and there's more than just these. These are just more of the common ones. Which one do you choose? How do you know which one to choose? It really depends on the scenario. Of course, you could easily leave this up to a vendor like PubNub to provide the solution for you, pick the protocol automatically for your device depending on the use case scenarios, and provide the best possible connectivity to your end target devices. So if you want the easy option, you could try it for free forever, and unlimited capabilities await you. Now, the other trick is we should probably just talk about these protocols in general because they are very interesting. They all have trade-offs, and in most of the cases, they're minor trade-offs, though some are pretty important. For example, WebSockets, WebRTC, and even WebTransport here, they're going to provide some significant barriers potentially being blocked all outright. There's scenarios where NAT networks, firewalls, corporate rules will prevent these kinds of protocols working. So it really depends on what your consuming audience, who's going to be your consuming audience. Because if you're going to pick these protocols, right, WebSockets, WebRTC, WebTransport, those protocols are going to have a lower level of compatibility for a lot of the scenarios, especially in business environments. Whereas server sent events and LongPolling, which are very close to exactly the same thing, these are going to provide the highest level of compatibility with pretty much 100% coverage because they use standard HTTP communication, which all systems need to have these days. Basically, if there's no HTTP communication, then you would never be able to access the web in the first place. So that's the biggest thing. It really comes down to compatibility. So for the highest compatibility and for really good overall performance comparatively, you'll want to use server sent events or LongPolling. WebRTC is peer-to-peer, so that means that basically you're looking for a scenario where you don't pay for bandwidth, right? So as a business, you don't have to pay for bandwidth. Your end users will just connect to each other directly. There's a lot of downsides to that because a lot of devices can't connect. They just won't be able to connect. WebTransport is the latest technology available in the world. You want to use WebTransport if you have the opportunity. It requires HTTP3, which is whatever system you're using must support HTTP3. But it is the best, most modern protocol available. If you have a choice, pick WebTransport. WebSockets are fine. They actually negotiate over HTTP initially, saying, hey, this is an HTTP request, but let's upgrade to a bidirectional communication over the same session, and that would be WebSockets. And so that's like, basically, it's an okay option, right? That also works fine. Like I mentioned, there are a few other things on here like MQTT, AMQP. These things, there's even more CoAP. These are additional protocols that they achieve the same thing. Communication between devices, servers, and those technologies, right? We need to be able to communicate between devices. There's more than just these items that are listed here. These are just these items that are mentioned 1, 2, 3, 4, 5. There's 5 different options here, but they're not the only options. They just happen to be the ones to pay attention to initially when you're thinking about communicating between devices. What are WebSockets? These are, it's a communication protocol. That's all it is. It's just a piece of paper. Basically, it's a way that describes how multiple devices, basically 2 devices, because in this case it's just 2 devices, are going to communicate with each other over TCP. The idea is it understands an exchange between connectivity between a client and a server. However, typically, you're going to want to communicate between more than just a client and a server. You want to communicate with a bunch of devices, a whole bunch of users. When that's the case, WebSockets aren't enough. WebSockets is just a communication protocol. You'll need to have extra logic built in for communicating and broadcasting events or redelivery of missed messages and other kinds of mechanisms like that. WebSockets alone won't support that, though the protocol itself is really useful. It's really powerful. Because what you can do, instead of the device needing to say, hey, guess what? I want to know when something happens. It needs to subscribe to information. And there's no way of knowing when that information is going to be available. The device, there's no way it knows. So it can take a traditional old approach of asking, hey, is there any new information every minute or which it's slow and it can be outdated, right? Every minute. And also every minute, 99% of the time, that device is going to receive information that, hey, there's no new information available. So it's a bunch of wasted bandwidth. And imagine multiplying that to 1 million devices. And you've got 1 million devices all asking for information where the answer is typically 99% of the time going to be no, there's no new information. It's just all wasted. This is where WebSockets comes in. This is why WebSockets is so powerful, because it allows you to open a connection to a server and ask the server when new information is available, send it to me. Otherwise, we'll just sit here idle. And that's really efficient. It's really powerful. And immediately when that server, like a database update changes, or another user triggers an action that needs to be broadcast to a bunch of users, that server can then broadcast that communication to all the connected clients. The update in the database occurred, here's the new information, and all the new information can be transmitted to those target devices, and it's the most efficient way to do it. Additionally, the idea behind WebSockets is it allows a 2-way bidirectional communication over the same TCP socket. That means that the client itself, like the phone and the web browser, it can also transmit data over that same socket. So that means that if it's making a lot of changes, it can transmit that data over that socket without having to use a second socket connection, consuming more resources. So it's more efficient from that perspective, which is really powerful. So we use WebSockets for real-time event-driven communication between client and server. Now, typically when you have a server involved, you're going to have multiple clients connected, and those clients might want to be subscribed to certain channels or certain events or topics. So that way, whenever one of the clients makes a change, the server with all the connected clients can broadcast those updates in real time. This is things like multiplayer games, chat rooms, push notifications. There are drawbacks of WebSockets. We do have to be careful because certain environment, proxy firewalls, these things will basically block WebSockets, right? They'll just outright block them because it's not a traditional HTTP API call. It's going to be a pattern of communication that these firewalls and proxies will simply just unfulfill. It won't work. And there's a lot of legacy technology out there that just will block it altogether. So you can use things like LongPolling and server-sent events, which use standard HTTP and will basically work 100% of the time. Otherwise, the device that's communicating wouldn't be able to communicate with the web at all. Those approaches are better for high compatibility. There is another challenge here. Connections aren't kept open on mobile devices. So when it comes to things like WebSockets, you're going to run into connectivity challenges, right? You're going to have to take more time to program resiliency into the client side of things when this types of scenario arises, because these devices, they have batteries. They want to make sure that they're optimally consuming battery power when needed. WebSockets are going to be closed and you'll run into issues. Often when you do implement WebSockets, you're going to have to also implement an HTTP streaming or LongPolling fallback. And the problem with that is now you just have this extra code for things that you might not need it, right? It's like, oh, so then if you're going to have to deal with compatibility, WebSockets might not be the right approach. It might not. And if the client goes away because it can't communicate over WebSockets, there's no way to know whether to redeliver messages that were missed. Did the device receive that data? How do you know? There's just not a good way to audit that information easily until you add more layers on top of WebSockets, and that's where the challenges come in. Now, it's a really good protocol if say your use case is you're just doing a game, all the data is just in the moment, like every second to second the data is throwaway, and you don't need any of the information, and it can be lossy. WebSockets are fine. This is actually a really good way to use WebSockets. However, if you want to better track and communicate and audit and have deliverability and success on connectivity and better reliability, WebSockets is less appealing. We also have a section here called short polling versus WebSockets. Now, typically, you never want to short poll. There's very rare scenarios where short polling is okay. Short polling is the idea where are you asking if the server has any new information yet, and the answer is always no. The answer is always no. It's always no until it's not that one time, and that's just the worst possible use of resources. It's a waste. Waste of bandwidth, waste of server, CPU, waste of battery. It's terrible. Also, you'll tend to draw back the amount of times that you ask the server, the frequency of the new updates, right? You're like, okay, if you ask every second, that's 60 times per second that you're making wasted API calls. You might draw it back to 1 minute, so every minute you'll ask. So that means now you're always a minute behind potentially, which is slow, and it's like, okay, what's the point in the first place? So short polling is usually never a good idea. There's one place where it's kind of okay. That is when you have a small number of devices asking one server, hey, is there any new information, right? 1,000 users, and it never really goes above that. Short polling, it's fine in that scenario. There's more than enough bandwidth to go around, and you can just, ask if there's any new information, and you're good to go. There's no need to go any further than that. When you scale, though, that's where the problem comes in, and short polling is no longer viable. And that's where WebSockets helps a lot. Now, we talked about short polling, but there's also something called long polling, and long polling is a way, it's sort of similar to server sent events. The device, the user, the web browser will make an HTTP call, and the server will respond only when there's information available. So it just looks like the API call is taking a long time to respond, but actually it's just waiting for, it's like subscribing to information, and the server will respond when new events are available. And then as soon as that response comes in, that data is delivered to the client says, perfect, thank you. Are there any new events occurring? And then the server will wait again. And so that's long polling, and that's actually really efficient. It's an extremely efficient model. It's the same as WebSockets from that perspective, because it allows you to efficiently wait for data, and the server will send data to the client. So if you are looking for a WebSocket-like solution and you want to make sure that you've got the compatibility, deliverability, reliability guarantees, performance, scalability, all those challenges when it comes to scaling communication web protocols like WebSockets, you're going to want to pick something like PubNub, which provides a developer experience that's a lot easier, because now you can easily segment events by channels, and you also get message redelivery when devices have unstable connections. But even more powerful, we run on all of Amazon's availability zones. This means that your devices will connect to the closest Amazon region, which is going to be very nearby, and it's going to provide the most performant connectivity available to your users. This is really powerful because it provides an uncanny amount of reliability, because when connectivity is unreachable with one of the zones, it will automatically reconnect to a healthy region. And any messages missed will automatically get bundled up, compressed, and delivered to the target device. Now that goes way beyond WebSockets, and it just adds a lot more into what you're looking for when you're trying to get devices to communicate between either server change events, right? Databases are updated, you need to push that data over to the user, or if another user performs an action that other users need to be aware of, like collaborative text editing and chat. Oh wow, look at this. Oh, I wonder, okay, so yeah, you get 200 users forever for free and a million messages. That's a lot. Free forever, every month. Another thing to watch out for is concurrency. So with when you're building your own WebSocket server, you have to worry about concurrency because you can only have so many users connected to the server at once. And typically, you'll run into either a kernel limitation on number of open sockets. That's a quick and easy problem to run into. Or the transmission rate and receiving rate of messages exceeds or exhausts resources on the machine. You run out of memory, you run out of CPU, you run out of network bandwidth. Those are the problems you could run into. With PubNub, for example, you get unlimited. It's just unlimited concurrency, and there's no bill or charge for that concurrency. You can have as many connected users as you want. Unlimited! Even if you have a giant spike in traffic. What are server-sent events? Server-sent events are a way to communicate from your server over to a target client like a mobile device or a web browser. Now you would say, of course, I've done that many times before, where I have an HTTP API call, a REST API call, maybe a Graph API call, some sort of API call over to a server. Now I'm communicating from my client to server. That's true. That's a way to do it. But there's a problem though. One of the problems is when you need to receive frequent updates or infrequent updates, just some sort of update occurs like on a database change event, something was written or deleted from a database. The client needs to know about that so that way it can update its view on the screen. Maybe you're using React or Svelte or some other JavaScript front-end framework. You're also maybe using Xcode or Android, and those events need to be synchronized to the device. Otherwise, the device will be out of date with the information it has. So instead of the device constantly fetching updates from the server to get the updated view, you can have it subscribe using server-sent events, which is a universal standard that's supported on every device and every framework. You import the server-sent event library on your platform and then connect it over to an API server. And the great part is it makes it really easy. It's one of the easiest approaches and can be implemented on basically every single server API and framework. Things like Next.js, Express, Python with Django. We've got PHP, we've got Ruby, anything that's a REST-based API, you'll be able to implement server-sent events. It's really simple, really straightforward. You simply import the SSE library, place in the URL that you are interested in the SSE to target, start the SSE listener, and then as soon as the server has any updates, you'll be able to finish that API call, transmit that data over to the end user, and now that user has up-to-date, fresh information immediately as it changes on your server. And it works with any data format. You can have JSON, you're probably using JSON, it also works with XML or HTML, and what you would do is the great part is that it also works with other frameworks like HTMX and React and Vue and Svelte and any other front-end framework that you're building and developing on. You can use JSON. You simply prefix the event, sort of like an event ID. It's sort of like maybe a timestamp. It's probably going to be a timestamp, right? A Unix timestamp. And then data, and then you pass in the JSON data. And so that's it. It's a really simple response format. And that's what the client is expecting. The client is expecting that response format. So then what it can do is it can keep that cycle loop alive, and then your device can stay up to date when your server responds with updated, fresh information. Now, this is significantly better, of course, than short polling, where you just continuously ask the server for new information, and the server responds immediately saying, hey, I have no new information. Terrible, because 99.9% of the time, the server won't have any new data for that. So what you want is for the server to be able to respond to the client only when new data is available. Now, it mentions here web browsers. However, guess what? This also supports on all mobile platforms. Every mobile platform, every mobile framework. You've got Android, you've got iOS with Swift and using Xcode and Objective-C, right? And then you've got Android with Kotlin and Java. They all have SSE libraries that you can import and then just point at an endpoint URL to your server, and then your server can just handle that API call. The content type for server-sent event is going to be text event stream, and it just streams events from the server to the client. Typically, you're going to have it JSON formatted, but it can be any format. It doesn't really matter what the format is. And it's actually pretty simple, even though the SSE library is included in all the possible, languages, you can, it's no different than just making an HTTP call with a GET request to the server. So you have an event field and a data field that provides the information. Oh, hey, check it out. It's right here. Okay, so here. Oh, event type, right? And data. The biggest benefit here of SSE, you're going to have a lower server load because as your number of users connect to your server, you're going to want it to be more efficient, right? Because you're going to be using more and more resources. So you want to lower that server load. SSE will help lower the server load. And it's a much simpler stack, right? Compared to WebSockets, SSE has a simpler client-side implementation. It's really simple. It's really straightforward. It's not much different than making a simple API call to an API endpoint. Also, essentially has full compatibility across all platforms and mobile devices, and you don't really have to worry about so much connectivity no matter where the device is located and what network the device is on. SSE is going to be a significant improvement. I really like SSE because it is a valuable tool. I like it because it's standardized, right? The industry has a standardized approach for real-time communication using this SSE approach, server send event approach, where the server sends events to the target device. It's efficient, it's easy, it doesn't have much overhead because it's basically just making an HTTP call to your server. And it works on every framework, every server, every language. And it provides all the benefits that you're looking for when you're trying to transmit real-time events between client devices like your phone and web browser. You can build chat, multiplayer games, update locations of orders and deliveries on a map. So all possible use cases. And if you don't have to worry about the protocol, if you use a platform like PubNub, where we provide all the protocols that you need automatically for you, and you don't even have to worry about it. All you have to do is use our SDKs on any of the platforms, and all of our SDKs can communicate with any other platform. So if you've got Python or PHP, Node.js, Ruby, any sort of backend server code, or you've got Android devices with Kotlin and Java, and you've got Xcode running your Objective-C or Swift. That's a lot of different languages. We have SDKs for all of those. And the cool part is, no matter what platform you're on, all those languages can communicate with each other. So you can build in-app chat, multiplayer games, and basically any kind of communication that you're looking for when any event changes on your server and your database, and you want to transmit that to your users. So your users have the updated information. That's what PubNub can do. It makes that really super easy. And you get up 200 monthly active users with over 1 million. That's 1 million transactions. So it's like 1 million messages per month. That's a lot. And that's free forever, every single month. It's kind of becoming a standard where developers need to implement the user experience of that real-time multi-user capability within their apps. It's just kind of a common standard these days. You see it in every app. All the top 10 apps in the App Store all have built-in communication technologies, right? Look at the social media companies like Instagram and TikTok and YouTube. They all have, user communications, notifications, any sort of events that change, right? The view counters, where the view counter goes up, right, and increases. That's all real-time communication. As data changes in the database, that gets pushed to the end user so they can see those changes in real time, and that's what PubNub does. What is LongPolling? It's an HTTP call to your server where the server will wait to respond until it has the information that the client requested. Now that kind of seems like, a normal HTTP call. The difference is, what is the difference? The difference is the client requested information that's not yet available or it's not yet ready. And so the server will then just wait to respond to that request until the server knows it has the information that the client wanted. And so this tends to issue long-running API calls where the client would normally get a response immediately from the server. The server will just wait until it has the information the client wants. Now that's long polling. Now then you'd be like, what's the opposite of that? The opposite is short polling, which is a pattern where the client continuously asks the server for new information, and the server will respond immediately, even if it doesn't have the information that the client wants. It just says, hey, I don't have the information, come back later. That pattern is extremely inefficient. You don't want the client to constantly get replies back from the server saying there's no information available, because that's just wasted bandwidth. So it's better for the server to wait to respond until it has the right information. And what kind of information is that? Well, guess what? It's going to be information that the client is going to want from database updates. Or if another user made a change on the system that got saved to the database, that database change needs to be propagated to all the devices that are connected. Now we want to compare that to all the different kinds of ways to achieve this goal, right? We can say WebSocket, server, sent events, LongPolling, WebRTC, and WebTransport. That's a lot of different ways to do the same thing. LongPolling, the way I like LongPolling is really simple, and it doesn't require any complicated frameworks because it's a simple HTTP call to your server. And that's amazing because now we don't have to import anything other than maybe an HTTP library, which you already have anyway. You already have that anyway. Like no matter what, you'll probably have an HTTP library already imported into your existing app. And LongPolling is going to be used for real-time web applications to receive, it says, near instantaneous communication, right? But instantaneous communication is kind of impossible due to laws of physics, right? So we have to say near instantaneous when we're thinking like millisecond level communication speeds, which is really fast. Like that's faster than you can blink. So if you're receiving an order delivery and you want to see the updates of where on the map the lunch order is, maybe it's a burrito or a salad or a taco, it's really important that I know where that order is because I'm hungry and I want to eat this because the lunch is on the way. That's what LongPolling can be used for. What's even better is it uses HTTP communication, which means that every device, every framework in the whole world essentially supports HTTP because this is the universal standard for all communication on the web today. What's even cooler is that it supports HTTP2 and HTTP3, which means that you can perform these actions over extremely efficient communication protocols like QUIC. And the specific benefit of that is you're going to have the fastest possible communication on time to first byte. That means that you're going to receive the data as fast as possible. And it's even better, all those other protocols that we were looking at earlier here were built to help improve that HTTP 1.0, the limitation of single socket, single connection, unidirectional communication. However, LongPolling and server sent events, they're both kind of the same. They're basically the same, just slightly different format. With HTTP3, we get all the benefits essentially of what those other protocols were trying to achieve in the first place. And so now you can use this really cool pattern, this really cool approach to receive updates efficiently and quickly and very fast, just amazing speed using HTTP2 or HTTP3 with LongPolling. And guess what? Better than these other protocols because it's super simple. There's no additional higher level libraries that you need to import. It just automatically works with those protocols and provides all the benefits. It's kind of like, okay, well, if you have to choose here, like I have to choose between all these protocols, but then I'm looking, at LongPolling or server sent events with HTTP2 or HTTP3, and they provide all the benefits plus essential compatibility across the board with fallback, performance, reliability, latency, excellence, efficiency, right? Low resource utilization, because we're only using one socket, right? With WebSockets, we were like, oh, we want to make sure it's bidirectional, but guess what? With server sent events and LongPolling on HTTP2 and HTTP3, it's still just one socket now for bidirectional communication. Isn't that amazing? The web just kind of upgraded itself to improve overall universal efficiency. All right, I know we have a LongPolling diagram. Here we go. Check this out. All right, so with LongPolling, we have a user device that it sends an HTTP call to the server, and the server won't have the information because the client is saying, when you're ready, server, let me know. I want this information. I want to know the next update of the car's location. Once you have it, send it to me. As soon as the server has that event, it's going to transmit that to the user, the device, right? Like usually the phone or the web browser, to give it the next geo coordinate. And it will be instantaneous, so you'll have the most recent, most up-to-date information. And it's extremely efficient because you'll only receive that data when the server has the update available. So it's extremely efficient, and that's what we like. We like that efficiency. It's amazing. And so the client will then say, okay, I got the data. Let me know again when there's more updates. And what's great about this is this pattern allows the server to also potentially pass back any updates that the client might have missed if the client wants that, which allows the server to have this resumption capability, which improves the overall reliability and guarantees of data delivery. And it's so much easier to implement because it works essentially on every framework and every platform. You can do this anywhere, and it doesn't require special formats or special libraries. All you have to do is just have a server that allows a long-lived connection with a long-lived request with a long timeout duration, and that's all configuration. It's all really simple, and all server APIs support this. And of course, we need the industry standard for TLS connections, The good news is LongPolling and SSE, they support these as well because their standard, TLS connections are supported across the industry for every application. And if you're considering a load balancing technique, guess what? Standard traditional load balancers, application load balancers like Apache, HTTPD, right, and Nginx, and then even any of your other applications, right, like maybe even in Rust, you might have a C-based light HTTPD. A whole bunch of servers can more easily round robin these connections between different systems because it's really easy, right? Now we're using traditional load balancing techniques. It allows you to distribute that workload across a large number of servers so you can easily scale. So if you're trying to build this yourself, it's actually pretty straightforward. And that's why I really like the LongPolling approach, because it works with everything's compatible with everything, and it's really straightforward and simple to build. So if you're getting started trying to build real-time user communications into applications, into your app, so you want multiplayer gaming or in-app chat where you've got users chatting back and forth in a chat session, LongPolling is actually really straightforward and simple way for you to get started. What is WebRTC? What is WebRTC? What is this technology? It's different than all the other kinds of communication protocols talked about before. Where it's different is it allows peer-to-peer communication. So you can have two devices connected directly without any server in the middle. This is the power of the open web, right? Where we have all devices being able to communicate with each other directly, which is amazing. That idea is fantastic because what it allows us to do is, instead of having to pay a lot of money say you're a business, right? And you want to be able to have real-time features built into your application, but you don't want to have to pay the extra money for servers to establish connections for devices to communicate when changes occur in your database, or users change events, or they delete data or they add data. You don't want the communication burden to be on your servers because you have to pay a lot of money for that. But guess what? With WebRTC, you can use peer-to-peer technology where your devices connect directly to each other. And now when the devices connect directly to each other, they can essentially broadcast their change events directly without you having to spin up infrastructure and pay money for it, which is amazing. Doesn't that sound really cool? I really like that idea because it's essentially a free business technology, and it adds these collaborative capabilities directly into your application. But there's a catch. There's a gotcha. You gotta be careful. One of the big challenges with WebRTC is it's very difficult, it's more complicated overall, and it has a high chance of not working at all. Even if you did everything right, there are additional mitigations that you can bring up another server as a fallback and have it communicate with that server for those broadcast events. But then now you're spending extra money, time, resources, development with that server for that extra compatibility. So if you want to go like the pure free route, as free as possible, what you're going to want to do is only enable features for devices that have that communication capability at that moment. And then essentially you have a free real-time collaboration experience that can occur, which is amazing. Like multiplayer games, a perfect scenario where you have two users communicating to each other directly, which is fantastic. This is a perfect scenario because as maybe you might have had a game host and then a client connecting into the host, the game host. Now you have a multiplayer scenario where the host sort of acts as that central hub, and that host will then connect clients and send those clients updates. That host will become the authoritative server, which then makes decisions on how the gameplay rules are established and how the end result occurs based on player movements. WebRTC has libraries for every platform pretty much, right? So whether you're building your game in C++, deploying it to maybe even Xbox or PlayStation or a web browser, WebRTC has all the frameworks pretty much baked in and built in for you to get started. Of course, there is a lot of extra work and effort. WebRTC isn't a free implementation. You're going to have extra client-side overhead because the clients are now responsible for all the communication and all the state management and exchange of information. So you're going to have extra effort. However, now that you're spending time just developing a robust client, you don't have to have any spend on hardware, servers, and infrastructure in order for your users to communicate. This is the beauty and the power of WebRTC. If you want to go this direction and have all your users communicate over WebRTC, you don't have to pay money for game servers. Doesn't that sound, why doesn't everyone do this? Well, there's that gotcha. Even if you did everything right and you built it in, there's a challenge that you might not get it to work at all. Due to double NAT and firewall restrictions, some clients will simply be unable to communicate on WebRTC. The most common use case for WebRTC is going to be video and audio streaming. So things like telecommunications, where you have video streaming apps like Zoom and Dialpad. You also have Google Hangouts, right? These are 3 common video teleconference softwares and tools that allow you to communicate over video live, and some of these technologies can use WebRTC. And that's another one of the great benefits about WebRTC, is that it can be more heavily focused on video and audio, right? Streaming binary data at low latencies. That's something that none of the other protocols deal with, right? So out of the box, WebRTC frameworks come with these video and audio codecs and an ecosystem that allow you to build apps that communicate in ways that allow you to stream audio and video in real time. So you can build a Zoom competitor. Yeah, well, we're going to talk real quick about one of the challenges, though, over WebRTC is going to be kind of a challenge because there's a lot to it. You've got your session description protocol, which are packets, HTTP packets, that are going to describe how the session exists and communicates between multiple users. Interactive connectivity established, which is ICE, which is a way for clients to negotiate a connection securely using encryption, right? Because you need to exchange cipher keys over that, so that way you can then be able to communicate in real time over RTP. And RTP can be packets like audio, video, and data like JSON, just like straight up JSON data. So any text-based data. That's a lot, and being able to establish a WebRTC connection does require some place where the users can meet in the middle, usually like a server API, right? So a client would be able to say, hey, I'm putting in my IP address information here, so that way another user can then fetch it from the database and then make a connection to me on my own system, on my phone or my laptop or my web browser. After the SDP information is exchanged, right, that session data protocol where we know each other's IP addresses and things like that, we still need to figure out how to traverse each other's networks, because we all have different network topologies, and we might even have double NAT scenarios or additional firewalls and proxies. Those are problematic and can even completely block all communication altogether. With ICE, we can traverse various patterns that allow devices to connect directly without having to worry about some of those scenarios. However, it's not perfect. There are scenarios where it just won't work, and then you still have to bring up your own servers in those cases, though they don't have to directly. Well, in some cases, let's check this out real quick. So with a stun server, it does help the client devices, when they're connecting to each other, traverse networks, so that way they understand where they can connect. So you can have a stun server that takes care of this for you. And when that fails, you're going to need a turn server, which is essentially going to be a server that takes and retransmits all packets. So it is a piece of infrastructure that is expensive, that you have to host yourself and pay for, right? It is a server, and then you have to round robin and load balance those servers. And that takes care of all the scenarios where you might not be able to connect directly over a peer-to-peer connection. This will be a broker that sits in the middle that can connect to devices, but you still have to pay for that bandwidth. It is optional. So say you do want to make sure it's as free as possible. Guess what? You can use open source public domain stun servers from Google and other providers just for the packet establishment, right? For the connection establishment. Now that can fail because of firewall restrictions. Though you could say that's fine. Users who are unable to connect just won't be able to experience those real-time features. And so you'd pop up a message on the user screen and say, hey, guess what? Your network is not compatible. You can try changing your network, turn off the VPN, or do other things, right? That might make it a lot easier for you to establish a direct peer-to-peer connection. And now you don't have to pay for servers, which is great. Just in some cases, users just won't be able to use those real-time features. Oh, interesting. So there are some alternatives for WebRTC, right? We've got the SIP protocol. Remember voice over IP, right? Oh, voice over IP. Right, where you've got phones, they're mostly communicating peer-to-peer or through some sort of broker that will be able to transmit voice, mostly voice, right? It was voice. You could also do video if you want. You could do video, although it was uncommon. Usually it was voice, also messaging as well, like text messaging, things like that, right? But SIP, Session Initialization Protocol, was built for that. And so you could kind of think of WebRTC as the digital evolution that works universally across all platforms. SIP can do that too. I would say WebRTC is just a step above because it brings with it a nice packaged ecosystem. There's also XMPP. I thought this was mostly for, it says you can do voice and video communication with it. I think things like video streaming, like live streaming, would be RTMP, where XMPP is maybe one-to-one. RTMP is a protocol that can be used to transmit your video stream to a provider like Twitch or YouTube, where they can take your data and then broadcast that on their platform. Oh, right. TikTok and Instagram also use RTMP for like TikTok Live and Instagram Live, which is RTMP is protocol technology for live video streaming that allows data to be transferred over the internet. So that would be like sort of an alternative to WebRTC. Typically, it's going to be a one-way. You could do it two ways with RTMP, but with WebRTC, it's intended for extremely low latency between two target devices, right? We're talking about like less than a quarter of a second latency. Whereas RTMP kind of typically is always going to be a second or more behind, which makes it more challenging for users to talk to each other. I don't want to have to wait a second to hear all your information before I talk back. It's not a sort of natural language conversation. So in this case, WebRTC versus WebSockets, you kind of really are separate. Yes, you can use WebSockets and WebRTC to achieve the same goal overall. It's just that WebRTC is more tailored to peer-to-peer and for video and audio, where WebSockets is more client-server and it's sort of custom protocol based on what your needs are. I like this one. There's an extra section here, WebRTC versus MQTT. They are both industry standards, right? They're both popular technologies. You're still going to use MQTT primarily for exchanging messages, right? Mostly text-based messages between target devices. There can be, you're going to have a server in the middle with MQTT, right? You're always going to want that. A server is going to be in the middle for MQTT to transmit and broker message delivery, where WebRTC is going to be peer-to-peer as much as possible and have the benefit of video and audio, all those things baked in and transmitting that data peer-to-peer. My favorite part about WebRTC overall is going to definitely be the free aspect, right? Where you can have devices communicate directly to each other without needing to pay any money at all from a business or an end user perspective to servers. You don't have to pay for that server. It just doesn't need to be there. You just can have devices connect up to each other. Now, you still need a central repository for the devices to know to be able to peer to each other. That still has to happen. But you don't have to pay for the bandwidth of the communication between the devices, which is the expensive part, right? That's where 99% of the expense comes in. All the rest of that bandwidth and that data and the communication happens directly between the two devices. And so that is very tempting from a business perspective. I like that one a lot. What is WebTransport? Have you even heard of WebTransport? You might not have heard of WebTransport because it's so new. It's not brand new. It's been around for a few years now. However, it is the latest evolution for real-time communication between devices. It lives and leverages HTTP3 technologies with QUIC so that it can establish connections between a client and a server using the QUIC protocol in HTTP3. Well, HTTP3 powers the majority of the capabilities of WebTransport for communicating server-sent events or, sort of a similar to LongPolling approach. WebTransport provides a nice little API wrapper library around HTTP3 and QUIC, which lets you communicate with your server and client efficiently. The idea is it takes advantage of all the HTTP3 technologies with low latency and high throughput connections between client and server for web and mobile devices. Now you might think, okay, well, I already have this with WebSockets or server-sent events and LongPolling. You're pretty much right. They're all very close and similar. Where WebTransport is different is it provides that just a little bit extra layer on top that makes communication a little more simple. And it gives you two communication option modes, sort of like a unreliable mode where you might be transmitting as many packets as possible, like audio and video data, where it can be lossy. Compare that to maybe game player movements that mostly need to be reliable. You can have that reliability mode also with additional built-in automatic recovery. They call it flow control, prioritization, reliable delivery, which are going to be common features and capabilities of HTTP3. It's just that WebTransport is a layer that lives on top that takes advantage of all that for you as much as possible, and it gives you a simpler API. Now, the drawback is it's still pretty new, and it's not going to be available on all platforms, or at least if it is available on your platform, there still could be bugs. You're going to get the best benefits from using WebTransport by taking advantage of the lowest possible latency because it requires HTTP3 and quick, right? And it's also going to give you the most improved efficiency because it creates streaming and it does extra. I wonder if it does compression. Do you think? Let's find out really quick. Oh, look at this. Okay, so here's one of the advantage with WebTransport, comparing that to with the old WebSockets, the legacy WebSockets. We have the ability, WebTransport builds in multiplexing and multiplex streams, whereas WebSockets, it doesn't include that idea. WebSockets doesn't. You have to build that extra logic into your WebSocket communication, where WebTransport includes that by default. So you're able to establish connections where you can segment streams over the same socket and connection. You can have multiplex communications and then subscribe to different topics and channels. Now, that comes with WebTransport, where WebSockets does not. Compression, yeah, I suppose you can compress. You can do your own compression. But is it possible that it automatically happens? I'm just very curious about this. So it looks like 4 years ago, this might not be the latest information, but 4 years ago is that the consensus is that compression is going to be implemented by the application. That means you have to build in your own compression design if that's something that you're looking for. For example, you can use Diffie-Hellman, gzip, those approaches, which keeps a dictionary in memory that allows you to create compression patterns based on the highest frequency of patterns over that communication. And then you can keep that dictionary, that header of information, on your server active, so that way you can communicate that dictionary to clients to provide fast compression, even if it's a brand new connection. And so you can use that pattern to provide extremely low bandwidth, but that's something that you have to implement yourself. There's just a ton of benefits of using WebTransport because it says we're talking about scalability. In terms of a large number of concurrent connections, you don't have to worry about that because your multiplexing is built in at the HTTP3 layer with Quick, and having multiple streams, you can easily multiplex over that same socket, which makes it easier for your server to scale because you're not exhausting resources as much. And also from a client perspective, they can multiplex with a large number of topics and channels. Also extremely versatile. You can implement any kind of real-time communication pattern, including voice, audio, video, real-time streaming, chat, and collaborative document editing, and you could also do multiplayer gaming with WebTransport. Of course, security is all built in with HTTP3 and TLS and then negotiation, so you don't have to worry about that. This is where WebTransport might be a little more challenging. It's an incompatibility layer where, yes, it's available on most devices and frameworks right now, though from a server perspective, you're probably going to have to create a dedicated stack just for WebTransport using open source WebTransport server technologies. So it won't implement nicely or automatically into existing languages. You'll have to use a separate stack for it. But if you're looking for the latest and greatest, WebTransport is going to be by far the most modern and intended to be the most performant and fast. And it is the next evolution. It is the pinnacle of communication between clients for real-time communication today.